Hello, folks. My name is Brian Schuster, and today I'm going to talk a little bit about a peculiar case, or I guess something I was curious about, and ended up making a pretty good lesson. So I wanted to share with you guys so you could learn a little bit about Solidity and understand how things actually happen underneath the hood. So Sahil the other day came up with this poll contract, and we started looking over it, and I was kind of looking at the way he created, this original contract, and this is what he actually deployed onto the network. So if you did the eighth activity and you were voting on this contract with this address. And what I noticed here was a pattern I didn't commonly see related to voting, or at least I haven't really seen. So if you look here, if you know anything about programming, you're seeing here that he's setting up an address called an address payable, which is just saying address payable, which is a Solidity concept, but you can just think of it as anything. And it has these two little brackets, which means he's defining an array. He's doing it for yes voters and voters. And then when he's going through the contract, if they have voted, if they've done things, he's basically looping through that array, adding voters, checking the length, things like that. And that's the core logic. This works just fine in practice, but the truth is that looking over Solidity contracts, I've been studying it, I didn't actually see this pattern be very often used. Usually what you see more commonly is you see people using mappings more heavily, which is more like a hash basically, where you would create some mapping and you would say, if somebody was a yes voter, no voter, you would have a number that you would increment instead. So we'd use some combination of, integers and mappings to basically define who voted and they went through. And the reasoning has always been, well, arrays are less efficient than, hashes. And so I actually wanted to try that out. I wasn't 100% certain if that was true here. So today I'm actually going to go through and do a case study of what happens if you use an array versus a map for the same exact contract. And so I coded up something and we can go take a look at it here. So first things first, let's talk about what an array is versus what is a hash. So if you actually go and look at it, go Google that really quick. An array, array Solidity. So, if you're not particularly tech savvy, what an array is you can effectively think of it like a list. And actually, if you look at this item here, this is a pretty good explanation of it. An array will be a list of items, and it can be anything. They can be numbers, they can be strings, they can be, or text or anything. Basically, put in a list 1, 2, 3, 4, 5, 6, and you basically store it as some sort of list inside your program. And you can go out and access it and go through and try to grab these items. So, for example, for this balance array, let me zoom in here just so you can see this better. If I decided that I wanted to loop through this list, for example, and go through, it would basically go and say, okay, I want to loop through every single item of this list. I go through one item, two items, three items, and then I would return back item one, item two, item three, and my program could have access to that to do something with that. If I did something like try to look for the first index, for example, or the zero index, because usually for programming it starts with zero, and say, okay, if I wanted to do balance index 0, it would return the 1 to me. Index balance 1 would return 2. Index balance 2 would return 3. If it returned 4, that would actually return an error. So when you're operating on an array, you have to make sure that you're not operating outside of the index. There's nothing that exists outside the index, which seems self-evident here, but when we talk about hashes, or mappings, that'll make more sense in a second. But effectively, you get, array is nice if you have like a set of items, or you need to go track out what items are there. So for example, what Sahil did is that he basically tracked the number of voters and basically went to check if you were a voter and were a yes voter, and that allowed him to basically do this get yes percentage by doing yes voters times 1,000 divided by get total voters. So he could go and see that, and in theory you can go and check to this in the future to say, hey, did I vote and did I do yes voters? We haven't actually done that here. Like you can't actually go and check that in this particular function, or maybe you can, but it's not particularly useful. You could go and actually check that, and it would be quite easy to make that happen. So you get some artifacts like you can check the length, you do that. So that's an array. Now let's go actually take a look at the other object that we're going to be talking about today, which is a mapping, which actually works like a completely different beast here. So as opposed to an array, which is a normal list, a mapping is a key value structure that basically creates a hash of values that exist out in, in Solidity. So as opposed to an array where if you make an array that says it's an empty array, it has nothing inside of it. Versus a mapping, basically you give it a key type, say address, for example, and then you give it a number. By default, every single address is, in theory, well, actually not in theory, in practice, is inside of this mapping. Every single one. So every single address that you could possibly come up with on the on the Ethereum network, every single one, you can go get a value back here. And what it does by default is mapping goes and just gives a false value to start. So for example, for an address, if this was a uint and you didn't change the value, it would come back as 0. If it was a Boolean, it would come back as false. If it were, I think a string or something like that, or an array, it would come back as an empty array. There's a list of what false values look like, or the default looks like, and already exist out there. So as opposed to a list where if I said, oh, I want to find index item 30, and that doesn't exist, it'll return an error. Versus here, every value by default exists here. So the only thing that the mapping is really tracking is when does the address, because it obviously doesn't store every single value. It doesn't do that. What it does though is it stores values that deviate from the false value. So for example, if I put in an address here and made it a 1, for instance, I said, my address has the number 1, this mapping would take a look and say, okay, now there's a different value. So that's something we have to track for. So when I go and try to update the mapping, and it looks just like an array, right? To go through. So you see balance, message.sender equals new balance. If I wanted to check to see if it, equaled something else, I could just put that here and it'll always return a value. If there's no value, it'll be 0. If it's, if I put in a 1 or 100 or 1,000, it'll return that value. And then I can reevaluate and actually say, now this value equals this number. So it's actually a pretty efficient tool to basically go and store values. The downside of it is that unlike arrays where you can actually get a length, like you see Sahil using here where he has voter.length, you can't do that with a mapping. You can't do that with a mapping. So you would have to have some other way to do that because every value exists there. So there doesn't really make sense to go grab a length to do that. But it is, in theory, a more efficient vehicle to go and grab it because as opposed to an array where there really is no key value ordering, with a mapping, there's efficient values underneath the hood. And actually, I don't know enough about Solidity to tell you exactly how it does that mapping. I would imagine it'd be some variation of like a B tree or something like that. But I'm just totally guessing there. To basically go find the values and basically return to you whether or not it's true, false, or whatever struct actually exists inside of the mapping here. So those are the two things we're going to be looking at here, and so today what I'm going to do is actually give you a use case that does a few things, and I'm going to try to evaluate the difference between array and mapping. So both of these are different implementations of the same core thing. And what we're going to be doing is we're going to be creating a registration application, a registration contract on the blockchain. And one of them uses an array as its core vehicle to do this. And one of them use a mapping and a number of voters to do the same thing. So at its core, what this function is doing is that I can go to this function. And actually here, let me zoom in here so it's a little bit easier for you folks to see. There you go. What we're going to be doing here is one, we want to make sure that I can add myself as a voter. So I can go and say, hey, I want to register. So I call add voter and it needs to add, a voter entry for me. Then I want to be able to go and say, get total number of voters. Basically, I want to see how many voters there are in total for this particular registration, whatever that might be. I want a function to see, did I register? So basically, I want to go and check to see, hey, I don't know if I registered for this. Can I make sure? So it's a read function to go through. And then finally, there's a function to remove registration. So what this function does is basically, if you exist in the voter registration, you're going to be deleted from that registration. You're going to be deleted from it. If you're already not there, it does nothing, basically. It goes through and functions. So both of these function identically. Array and mapping, or at least that's the intention. I didn't go and seriously test this, but they do the same thing. So let's take a look at what they do. So for the array, we have just one variable at the very top. We have this address private voters at the top. That's going to be allow us to do everything. For add voter, what we're doing is we're going to do voters.push message.sender. So I'm going to go add voter here, and I'm going to be added to this, address. Now, if I was doing this correctly, I would have some sort of require function here to make sure I can't double vote. So you could, in theory, double vote here if you wanted to make a case. So there should be like some require statement here to stop you from double voting. Maybe using this did I register function as some internal function to do that. But for now, you can double vote. We don't really care. So, we have a voter.push. We have a, there, and that'll just push a new value to an array. Then the next thing we're going to do is we're going to return, to get total voters, all we're going to do is just get the length on that array. It's the easiest thing about arrays to do that. You do that voters.length and it'll tell you how many are there. If you have none, it'll be 0. If 10 people voted, it'll show back 10. Easy. The next thing for did I register is where things get a little bit more complex, at least for, the Solidity's sake. And you'll see why it's complex when I show you the mapping example. So did I register will return a Boolean, which is true or false. And then what I'm going to say here is for uint I equals 0, semicolon, I less than voters.length, semicolon, I plus plus. If you're not familiar with that, it means you haven't done much JavaScript, because this is the standard way you iterate over a list. What we're doing is basically we're starting at index 0, which is the very first item in the array. And then we're saying for index 0, while I is less than length, you're going to iterate over and do that. So I'm not going to get into the specifics of the array here. I'm just going to assume that you at least are familiar with that nomenclature. But if you're not, I would encourage you to look up for loops and how they iterate. But effectively, this is going to go through every single item until we get it to, something stops the for loop. We either get to the end or something stops it. In this particular case, we're looking if message.sender, and that's the person who's sending the transaction, equals the voter ID of I. So remember, we're throwing addresses in here. So that means that if the message.sender, which is in my address, equals that voter, it means I'm registered in the list. Did I register? Yes. Return true. This return will stop the for loop. It'll return a Boolean and go through. If I'm not in the registration list, it's going to go through this entire array and go back and return false. So if it's false, I have to go through the entire list. If it's true, I just have to return, up until that point. So it returns false. So that's that. The final function is the remove registration. So what we're doing in this case is we're using the same for loop logic to go through the entire list. And basically, if message.sender equals voter, same logic up here, we're going to delete that voter from the registration. We're going to remove my name from it. And then we're going to break out of the for loop. So this is a special line that basically says, stop the for loop, go to the next line, in which case there's nothing. So the function just ends. And so that's what's going on here. So that's what's going on in the array. Let's take a look at what's happening in the mapping. So up here, instead of having one value, we have two. We have this mapping for, address, to Boolean for voters. And again, very similar to this one here. And then we have this number of voters. This number of voters is necessary because we no longer have a length we can rely on to reliably give us that number. So now there's a second variable we have to deal with. So that's a little bit of extra complexity. For add voter, I basically go and say voters.message.sender. So now we're creating a new hash mapping up here, and we're saying it's now true. Remember, by default, it'll be false. But now we're saying I'm adding myself as a voter, so add me as true. I'm voting. And then the number of voters is increasing by 1. That's what the plus plus means. So that's how we add voters. To get the total voters, we don't even have to do a length. We just have to get the number of voters. So by default, it's going to be, you're going to get a 0 here. And actually, I'm not sure if that's the case. So honestly, we may actually have to do a constructor. I think that's okay. We'll see if that works. If it doesn't work, we'll go and add a constructor to the beginning of this to make the 0. But when we add the voter, we get the total number of voters, we get that number, and it's 1,000, or 100 or whatever the number is. We just return this number because this add voter is working. Did I register actually gets real simple here. So over here, we had to iterate over the entire array to get the number. Here, we just return voters.message.sender. All of that logic to actually go and hunt down the exact address is all handled by this mapping. it's all handled by the hash mapping. We don't have to go and come up with our own logic. So in this case, this is significantly simplified, and we're returning whatever returns here because it's already, established a Boolean. So we just established that Boolean and return that. So that's significantly simpler. This remove registration is also simple, but you got a little bit of complexity you need to manage here. So again, remove registration, remove my registration from this list. So what's happening? If the voters.messenger equals true, so again, we're relying on the same logic to go and pull this. If it equals true, what we're then going to say is that voters.messenger now needs to be flipped to false. So we're now flipping it back to the value that says false, that I'm no longer registered, remove my registration. But my number of voters needs to increase. Because remember, I added myself to the number of voters, so that's incremented by 1 when it shouldn't be. So we need to go and remove 1 voter. So that's what this minus does. It de-increments by 1 to go through. So this logic, way simpler than this one in my opinion. So this is already a win in this case to do this. You have to add this additional number here, and there's definitely some funniness here. Like this is one that I would test this before going out here because I'm not convinced that this is 100% working. To go through. I mean, there's a number of things I would do this if it was in production, but this is enough for us to actually go through and go and get some good numbers. So, anywho, we have this logic, so how exactly we're going to test this? So, where this is going to fail, my guess, because again, where this is going to fail is when you have lots and lots of contracts. Because here's the thing. The real kicker here is that this mapping is going to be, in theory, it's going to be efficient no matter how many numbers you have there. If this index is working correctly, and again, I don't 100% know how it operates, but if it's optimized well, this is not, no matter how big this grows, this is going to be pretty easy to maintain. It's going to take up more storage on the blockchain, obviously, but it's going to be pretty easy to go and get that logic down and, be able to search, for this particular addresses and see if it's true or false or whatever. Versus the array, you're always iterating from the beginning to the end. So if you get like 1,000 transactions, you have to iterate over 1,000 different variables each time to go and find that number. And again, 1,000 transactions is pretty big. I mean, you think about it like, most smart contracts that exist on the network, like NFTs, like have 1,000, contracts sitting out there and, maybe 20,000 or 30,000 buyers or things like that. It could go up to millions, but we're still in the order of magnitude where 100,000 people interacting with your smart contract is beefy, So what I wanted to see is if I pushed 1,000 voters, to the network, how would that handle this? So, how would that handle? So here is my test deploy. So we're going to deploy to the local Hardhat network. So this is one that gets spun up with Hardhat when I go and run it. I'm going to show you all the commands I'm going to do to go make that work. And basically we're going to do a test to see, does this actually make sense? Based on this, how fast does it return various different functions? So what we're going to do is we're going to go through and throw 1,000, random accounts at this. We're going to add 1,000 voters, and then we're going to see the number of voters, adding new voters, and removing registration, and see if there's any difference in timing and gas, how much gas it takes, and those sorts of things, just to see if it bears out. Because again, in theory, I would think this would be slower, but we don't know. That's why we're testing. So if you haven't seen this before, I'll go through real quickly. We're taking in the Ethers contract, the Ethers library, which is the, how we interact with the local blockchain. We're grabbing the deployer, which is going to be the first contract here, and then a bunch of addresses, behind that. So what these 3 dots means is basically saying, go get all the signers and unpack them into these ... address, this array, basically. We're in JavaScript, so we're dealing with an array. And I updated the Hardhat network here inside of my hardhat.config to include 10,000 accounts. So I'm only dealing with 1,000, but I added 10,000. So when actually, it ran a little bit slow last time. So I'm going to actually bump that down to 1,010 to go. So I give myself a few extra to play with at the end. So basically, by default, your Hardhat creates 20. I'm creating over 1,000 so I can do my test. So it's going to, so it doesn't care how many there are, they're going to unpack them here. I'm going to get a default provider, which is just how Ethers is going to connect to the network to go through. I'm going to deploy both of these contracts. I have an array contract and I have a mapping contract that I'm going to go and get the addresses to send here. I'm going to console that, log them. And then we don't actually need this random integer because I found a much better way to deploy the contract. So defining a next address, and then here's my for loop again. This is exactly like Solidity had it. And basically, we're just going to loop through 1,000 values inside this addresses value. So the next address is going to be the index of whatever number we're at. So address 0 is the first index. Then you're going to get the second, third, fourth, all the way up. We're going to print out that address, and then we're going to run two contracts. One is that we're going to connect to the mapping contract with next address, and then we're going to add a voter, and then we're going to do the same thing for array. So we're first going to go as address 0, which is just going to be something random. We're going to go through and add a voter, and then we're going to go to mapping and add a voter, and we're going to look at this. Basically stress testing this contract and seeing how it works. And then after each one, just to make sure, I just do a little console.log to make sure we can get the total number of voters. And then I'm just printing the mapping out again, just so that we can see it at the end. Just so we can see that, because we're going to need that address to run this next part here. So even though this is, about Solidity address versus mapping, it's also a little bit about Hardhat. So let me go and open up my window. So this is, I'm on Windows, and I have two consoles running here. So I'm inside of my, my library here where I just did all this. The very first one we need to do is we need to run the actual deploy that I just ran. So what we need to do is we need to run npx hardhat run. The network needs to be localhost, so we know that we're deploying here. You don't want to be deploying this on mainnet or anything like that. It should fail, but you don't want to lose all your Ethereum. And then I'm running the scripts.test deploy. So I'm going to press enter. And at this point, I may need to pause this because it's going to take a while. Because again, we're doing 1,000 contracts out here. So the compilation worked. Oh, cannot connect to the network local host. Failed, reason, error, connection refused. That's because I didn't create my local host. So the very first thing I needed to do is I need to start the console. What does that mean? So I'm going to start npx hardhat, and we're going to need to run a node. What does that node say? It says start up a local host that basically has a network created that does, that I can connect to. So this is going to inherit from this hardhat.config, and it's going to create a 1,010 accounts. And as you can see, we created 1,009, which is the first one is 0. So it went and created these addresses just now, and it went and started up. So now it's available and and we'll go through. So now we can rerun this to say npx hardhat run network localhost, because now there's actually something running locally. So if I go and run that, it should, in theory, run. So let's see. Yep, take a look. All right. So what's going on here? At the very top, we got the function running that we went through. For each individual address, that you're seeing streaming through, we're running an array function and we're running a mapping function, or the add voters on the array contract and the array funny on the map, and the mapping. So, oh, look at that little bug. So it was saying array, but it's really array and mapping. So I'll say this. So the next time we run this, it'll actually come out correctly. And it's going through and doing, and it's adding all of these. So this is going to take a minute to go through. So while this is happening, I can go through what's going to happen next. We can actually prep the next part of this. So what we need to after this deploys, it's going to be ready to go. We need to then create a console that then logs into the local host. But we need to be able to actually connect to this contract. It by default's not going to know what array or mapping is. I'm connected to the local network, but I have a new instance. So first thing we're going to have to do is we're going to have to get the contract, the ABIs. So let me go here and here. So an ABI is effectively like an API, as you might think of it. What's an API for, software? It basically tells you, here's your functions that are available for you for the service. You can, if you're going to do this function, you're going to get back a certain value, an expected value. You have to tell your contracts that this ABI actually exists. Now, for like some very, very common smart contracts, like for example, ERC20s or ERC721s, there's something called an interface on these that now are standard out of Open Zeppelin. They've been, standard for a few years now. So you don't always need this, but because this is custom, I need to go and create this. So the first thing we need to do is we need to go and grab these ABIs for these different functions. And we also need to grab the contract. And that's not up here yet. Let's see how far we've gone. Okay, we're only about halfway through. So what we're going to have to do is when this contract goes through, we're going to have to create Hardhat. We're going to have to create ethers and go through here. We're then going to have to get a provider set up, and you can just use default provider. That's perfectly fine. I want to get the deployer because the deployer is going to be the guy, and I'll probably call him owner, is going to be the thing that needs to connect there. And then what we're going to do is we're going to run through all these different connections. So anywho, I'm going to pause this real quick, and we will be back in a second. Alrighty, so that took about 7 minutes or so. We now have 1,000 contract or 1,000 transactions for each one. So we have over 2,000 in the network. And now we have our mapping address and our array here. So we're good to start the next bit. So I'm going to take these 2 contracts and I'm going to put it into my Scratch folder here. We're going to need them in a second here to actually go get access to this contract. So let's go ahead and get started. So I need to go and get to the local network here. Let's see if it's back here. And now this opened up my console to local. So I'm going to go ahead and steal some stuff here. So the nice thing I really like about Hardhat, and I'm not sure if this is true about Truffle or other frameworks, but because it's ethers and because it's Hardhat, you can use basically the same things you use in your contract inside your deployment. So I'm going to just steal liberally from here to get everything set up. So I'm going to paste this, and now ethers is ready and set up. So I also need to go get my signers. And I'm not going to run this full thing. I'm going to copy it. And we need to change it slightly here. So we're just going to do the deployer. And we're not going to do the rest of the addresses, because we just want to deal with one contract here, because that's all we're going to be testing out. And we'll be able to see everything run here. So we run that. We now need to go get the provider, because we're going to need that to be able to connect to the contracts. So get the default provider. Now is the first change. So the first thing we're going to do is we're going to get connected to the array contract. So we're going to say we're going to first start to do the array ABI. Oh, and let me turn off my keyboard so you guys listen to this can hear me. I like my keyboards loud and I don't apologize. So I have a provider, my ABI here. So this one is a little bit weird, but I have my array. Here's the array ABI. In theory, it should be the same, but I'm not going to do that. So here's the array ABI equals here. I'm going to paste anyway. And if it comes back undefined, it worked. So we're now going to do let array contract, because we now want to get to the contract. We need to put this in quotes, as I found out. Otherwise, this won't work. We need to get the Scratch. Array address is here. And now we're going to get the array contract. So, got the array ABI, got the array address. Now try to make the contract. So we're going to say let array equal new ethers.contract. And then we're going to first give it the array contract. Then we're going to give it the array ABI. And then we're going to finalize it with the provider. And that should be good. So let's test this out really quick to make sure that it worked. So in the array, we got this get total voters to go through. And so we're going to test that to make sure that went through. So we're going to do await array.connect deployer, because we need to connect a contract to make this work. Get total voters. And boom. So we have 1,000 voters. That seems right. So the array's set up. So we're almost ready to go ahead and do this. So let's now go set up the next value, which is going to be mapping. So we're going to do let mapping contract equal. So let's go to the Scratch. Let's do mapping. I'm going to copy this over. Comes back undefined. Great. Now we're going to do mapping ABI. And we're going to grab the ABI here. Go through and do that. Paste anyway. Goes through. Now we're going to call this let mapping equal new ethers contract. We're going to do mapping contract. mapping ABI, and then we're going to do the provider, and that works. So the really nice thing that we can do, well, we have too many values, so it's going to be easier to just type it out. So mapping dot, oh, nope, I did not have that in there. Let's go and grab the default, one of the easy ones, get total voters. Great. So we're going to connect to deployer again, get total voters, and go through. Fantastic. So now we can actually go and see what's going on here. So first things first, I want you to notice what's actually going on. So I'm going and getting the number of voters here, and you notice they both returned pretty instantaneously. So what's going on? So in theory, this one should be about the same, right? Because if you take a look what's going on here, in this case, we're returning the voters.length. And in this one, we're returning a number, an int. Both of these are both just numbers, right? One of them's attached to an array, one of them's there. So the difference is pretty negligible. However, the first one that I want to go into is then basically adding a new voter. Let's do the, add the new voter. So now we're actually changing the state of the function just to see how fast it goes through. So here's add voter, and for both, one's a push to an array, one's a mapping. So let's go and do that transaction really quick and see if we notice that anything. If you look at the bottom, you'll see this, you'll see the transaction come through. So we notice these are both pretty quick. Let's see if the next transaction is just as quick. So we have to await. We're going to do array.connect deployer. And then we're going to do add voter. Let me get the case of that right. Add voter. I'm going to end. Alrighty. So this actually went through. Here's the value we really want to pay attention to here. The gas used. So we used 48,464 gas to be able to run that transaction, and it was included in the last block. So that's kind of our benchmark. If we use that much gas, into the transaction. So now we get an idea of how complex it is. Let's go and change that now. Let's do mapping. And because it's the same exact contract, or the same exact function, we can just do mapping. Now let's click the mapping. Now we see there was a gas difference. It's small. I'm not even sure if that's a couple percentage points. 48,602. So the first function we ran, which was the array, actually came back slightly cheaper. Not enough that I think that any users would actually notice. I mean, even in very, very expensive gas situations, that's pretty negligible. But it turns out that if you had to change the state and you push and map, they're actually that there is a slight difference, and it's in favor of the array. And if you take a look, we can kind of reason our way around that to figure out why that is. Even though we're adding a voter, even though the array is massive, all we're doing is adding a function, adding a new value to the end of this contract here. We're not reading the state. We're not going through and checking a whole bunch of values. We're not doing that. We are just going and adding something right to the end. It's a push function. That's what it means. So because of that, it's not really doing that, we're not really doing that much work. So this mapping, as it turns out, is a little bit more, complex. And actually, you can see here, we're actually doing two functions. So instead, we're making this true, and the number of voters is incrementing. So that might actually be the difference between the two of these, this, number of voters. So it ends up being a little bit more expensive to do it this other way, but kind of negligible. So that's the first test I wanted to do, which surprised me, but now that I'm reasoning through it, kind of makes sense. Now let's go and run the next function, which is actually seeing if I voted. So this is the first big difference between it. Did I register? Because here, my mapping just has to go through this hash. It's very simple logic, it has to return that. Versus here, I have to go through this whole function. So let's see, did I register? So we're going to start with the array. Await array dot connect deployer. Did I register? Let's make sure I got the language there, or this key right. And we're going to run this. And we're deploying true. So we did that for the array, and notice no transaction came back. So this is kind of a hint at something's going on that we didn't quite expect. And returns back true. So notice, watch, the array took like 3 seconds. The mapping came back instantaneously. Why? So we know the deployer is at the end of the loop. We know that we have 1,000 values, and we know it's sitting there at the end. So we know it has to, and it loops through the beginning. So it has to go 0, 1, 2, all the way to 1,000. When we do the array, not quite a second, but right there, versus mapping is instantaneous. So we're already seeing a difference in how fast it returns. Now, because of how short the list is, and again, 1,000 isn't massive, but it is, it's a little bit bigger. You have to loop through all these values to get to this message.sender, and then it returns back yes. If it's at the beginning, it'll probably return back quicker, but there's no guarantee of that. I could be in the middle, I could be at the end. Versus, I added this mapping at the very end here, and it returned back lightning fast. So, for very, very large lists, it's clear this mapping is going to be more efficient. It's going to be a more efficient way to do work. Because when you're going through this push here, you're kind of arbitrarily adding people to the list, and it means that it's going to be inconsistent across the board. However, that's still not that big of a deal. Like, right, if you had an array and you had to check it out, this versus this, it's not like it's that bad, that big of a deal. And there's another reason why we're not actually seeing that big of a problem. These are reads, right? And this is something that I forgot when I first set this up, and the way Sahil set it up and why it's really not that big of a deal for, the game. Reads don't cost anything. So even though we are asking the function to do a fair bit of work, even though we're asking it to go through an entire list of values and look through the blockchain and go through all these different values, it's still only a read function. It has this view function on top of it, so it's not actually writing anything to counter, which means only one server has to do the work here. Even if you have a list of 1,000 things or a million things, only one node is actually going to be doing that. And doing a for loop is not really that expensive. So from a transaction perspective, it is equally expensive, at least from the end user's perspective, to go and return this. So the reason you don't get a transaction value for both of these is because it doesn't cost any fee. You don't have to actually go through and do that. I'm not even sure if I actually needed to connect here. Let's actually see if we do that. Do I even need to connect a deployer to make this work? Yeah, we do, because we need to, that's right, we need to know the deployer. So let's get my mapping back. There we go. So we need to know what value we're actually dealing with here to do that. So, okay. So from that perspective, that actually, the mapping is clearly superior, but not that big of a deal. But there's one more thing I wanted to test, and this I haven't actually looked at yet, so I'm actually a little bit excited to see what's going to happen here. Remove registration. So here, I'm just viewing the blockchain. Here, I'm actually changing the state. So we need to see what gas is charged here versus someplace else. So let's first start with the array. Well, we have always done the way. So now we're going through and saying this. So we know the deployer is registered. It came back true on both. So now we're going to remove their registration. So we're going to do array connect deployer registration. Now let's see what happens here. Remove registration, public, and go through, and I don't need anything else. So I haven't tested this, so this might break here. Let's hope that doesn't happen. Oh, okay. Well, 2.6 million gas used. Okay. That's something. So we can go back and actually see if it worked. Okay, so it's false now. So it definitely did what it needed to. But let's see now. Did I register? So here's the array.connect deployer. So the array just took a ton of gas. Like, that was massive. Because before, you take a look, if I was adding voter, it only cost 48,000. So this is like Orders of magnitude bigger. Now let's see what the mapping does. Wow. Look at that. Look at that difference. 27,000 on the mapping. So 27,000 versus 2.6 million. 2.6 million. Okay, that's bigger than I was expecting it to be. Way bigger. So let's go through and connect to see if I registered. And it says I didn't register. So, okay, so that ended up being a better demonstration than I expected. I was suspecting that the work would take there. So it took like upwards of, what was that, 3 seconds or something like that? And you can just see it in the amount of gas, 2.6 million gas versus 27,000. So that kind of illustrates the point. So let's go back to the lesson here on what we learned. So there are some downsides to the way that mappings worked. Like, for example, even though this contract, and again, Sahil's contract didn't have an auditing function, but if I wanted to go and do a general public audit of these things and I wanted to save that in the blockchain, I couldn't audit it on the blockchain. Now, what I could do instead is I could basically emit an event, and this is for another day, is I could probably emit a searchable event instead to go through. And instead of trying to save all the voters on the blockchain, which as you could tell was very, very expensive. That's a very expensive way to go about and doing it. I can emit an event and just go search the sidechain to go through and do that instead of having to deal with the array. Because if I have, for adding voters and reading, so for these 3 functions, it's basically negligible. I can read it, I can write just fine. But if I have to write to the array, if I have to make a change to the array, expensive. Versus with mapping, even though I can't audit it in this particular, manner, I can still create an event to go through and do many of the same functions. So at least for this value, it does the exact same thing. It counts voters, it sees how many people are there, it registers you to vote, you can remove yourself, and it just ends up being super, super easy to be able to go through. So anywho, I hope you enjoyed this, demonstration of mapping versus array. I certainly got very excited there to see just how clear it is, especially because I've never ran this before, just to see how much it goes through. So anywho, if you have any questions, please let me know. I'd be very happy to discuss this further. Anyway, thank you very much for spending some time with me today.